Hi everyone, in this video I'll explain how you can balance chemical equations using the half reaction method. So remember, for any redox reaction like this one between magnesium and oxygen, you can write its half reactions by going through the 4 steps listed above. First, identify which atom's oxidized and which is reduced. I can see here that magnesium gets more positive, so it gets oxidized. Oxygen gets more negative, so it's being reduced. Then you separate out those atoms and show the changes for just the oxidized atom, Mg going from 0 to +2, losing 2 electrons in the process. Same thing for the reduced atom, oxygen goes from 0 to -2, gaining 4 electrons in that process. What should have struck you as odd in this half reaction writing process is the fact that magnesium is losing 2 electrons, and yet oxygen is gaining 4. And how is that possible? And in fact, it's not possible. The issue is that these two half reactions are not balanced. So in this video, we'll talk about how to balance the half reactions once you've got them written. So most of the time, this is referred to as the half reaction method for balancing. We'll start off in our first example looking at our Mg and oxygen reaction just because we're pretty familiar with it. Also, the first step of balancing with the half reaction method is of course to write the half reactions. So we've got to go through all 4 of these steps from the last video. We already did that in this video at the beginning, so here's my 2 half reactions for Mg and O2. Once the half reactions are written, you have to multiply both of them or one of them until the electron quantities are equal or until the electron quantities are balanced. If oxygen is gaining 4, magnesium has to also be losing 4. Remember, magnesium is transferring those electrons to the oxygen, so whatever the magnesium loses, the oxygen has to gain. The way I can make these electron quantities equal is by multiplying magnesium's half reaction by 2. So instead of 1 Mg, and 2 electrons, everything is doubled to 2 magnesiums and 4 electrons. The third step is to add the half reactions, and if you've done your job properly, the electron quantities will cancel out. So let's add these 2 half reactions together. Just like any time when we add chemical equations, anything that's the same on the opposite sides will cancel out. So my 4 electrons here will cancel. Summing up the 2 reactants, we've got my 2 Mg's plus my O2, bringing down the 2 products, 2 Mg plus 2's and 2 oxygen minus 2's. So technically we're finished. We have balanced these 2 half reactions. The electrons are equal and they canceled out. The only other step might be if you were given an original equation. So that's this one at the very bottom, the equation we started with. Sometimes you've got to take the coefficients from your net added equation and sort of add them into that. So I can see there's 2 Mg solids right here. I just have to add that coefficient of 2 in front of the Mg solid in the original equation also. O2 doesn't need a coefficient. This 2 and this 2, those particles are both found in MgO. So if I just put a 2 in front of MgO, that gives me the 2 Mg plus 2's and the 2 O minus 2's that I needed, making this final equation on the bottom the official balanced reaction. So here's a look at those 4 steps one last time. Those are also the key ideas for this video. Make sure you pause and take a moment to write them down. So let's take a look at a couple other examples. Here's copper solid reacting with Ag plus 1. This is a great example of when you sometimes need the half reaction balancing method, because this equation right now looks to me like it's balanced. 1 copper in the reactants, 1 copper in the products, same thing with the silvers. But when we write out the half reactions, you'll see that it's actually not balanced. So let's start off with step 1 and write the half reactions for this equation. First, I'll assign oxidation numbers to all of these atoms. And now I can separate them out and show how the copper changes, getting more positive by 2. So copper is my oxidation, losing 2 electrons. And my silver getting more negative by 1, so it's my reduction and gaining 1 electron. So this is what I mean by this equation looked balanced but is not, because copper is losing 2 but silver is only gaining 1. So we have to fix that electron balancing problem. And step 2 is how we fix it. Multiply the half reactions until the electron quantities are equal. I can make the electron quantities equal by multiplying my silver reaction by 2. Since I'm multiplying everything by 2, it's no longer 1 electron, now it's 2 electrons. That was the purpose. but it's also 2 Ag plus 1s and 2 Ags. The third step now is to add my two half reactions, and if I did a good job, the electrons should cancel off. So I've got two electrons on opposite sides, that means they will cancel. Now I've just got to bring down the reactants and the products. So after carrying down my two reactants, I've got copper reacting with 2 Ag plus 1s, and bringing down my two products, I've got two solid silvers and a copper plus 2. Step 4, if an original equation was given, I'll take those coefficients and add them into it. We can do that here by simply putting that coefficient of 2 in front of the silvers in my net original equation, making the official balanced reaction have coefficients of 2 in front of Ag. And let's take a look at one more slightly more complicated example, beginning by writing the half reactions, which requires me to assign oxidation numbers. You can see them in yellow. So one of the half reactions is going to be aluminum 0 changing to aluminum plus 3. It's getting more positive by 3, so losing 3 negative electrons. And the other half reaction is H with a plus 1 changing into H2 with a 0. Don't forget to balance the atoms in this. My H2 requires there to be 2 H plus 1s. So plus 1 to 0 is getting more negative by 1, but that's per hydrogen. So instead of 1 electron, there's 2 electrons being gained. So I can see right away these electrons do not balance. Aluminum loses 3, hydrogen only gains 2. This is a case where I have to multiply both of the half reactions. My aluminum one has to be doubled. That'll give me 6 electrons. My hydrogen one has to be tripled to get that same 6 electrons. And because this one is a little more complex, you can see I've erased my original coefficients and added the new ones in cleanly in red. Step 3 is to add the two half reactions. If I did my job correct, the electrons should cancel off, which they do. Now I've just got to pull down my two reactants and my two products in the net equation. So here's my net equation at the very bottom. The balancing has been completed. We just have to do step 4 and add these coefficients back into the original equation. My aluminum solid needs a coefficient of 2, so that goes right there. My H plus 1s need to have a coefficient of 6, so 6 can go in front of here where the H plus 1s are. My H2 needs a coefficient of 3, so I can plug that in there. And my aluminum plus 3s need a coefficient of 2. So here's the final balanced equation with 2, 6, 3, 2. That concludes this video on the half reaction balancing method. Thanks for watching.